We have to find whether the given rational number, we have the number 13 by 3125. Without actually dividing 13 by 3125, we are going to say whether it is going to have a terminating decimal expansion or recurring decimal expansion. For that, first let us prime factorize this denominator. When you divide by 5, you get 625. Again, when you divide by 5, you get 125. Again, when you divide by 5, you get 25. Dividing again by 5, you get 5. Dividing by 5, you get 1. So this 13 by 3125 can be written as 13 by 5 power 5. For a rational number to have terminating decimal expansion, it should have only powers of 2 or powers of 5 or both powers of 2 and 5 in the denominator. It should not have any other numbers in the prime factorization. In the prime factorization, you can have powers of 2 or powers of 5 as you have here, or both powers of 2 and 5, except that no other numbers should be there in the prime factorization left out. In this question, you can see that you have only powers of 5, so you can say that it has a terminating decimal expansion. We have 17 by 8. Without actually dividing the number 17 by 8, we are going to find out whether it is going to have terminating decimal expansion or recurring decimal expansion. Now we will prime factorize this number 8. 4 2s are 8. Again dividing by 2, you have 2 2s are 4. Again dividing by 2, we have 1. So this number 17 by 8 can be written as 17 by 2 cube. For a number to have terminating decimal expansion, it should have only powers of 2 or powers of 5 or both powers of 2 and 5 in the prime factorization of the denominator. There should be no extra number. Now you can see that here it has only powers of 2. Therefore you can say it is terminating. The number we have here is 64 by 455. Without actually dividing 64 by 455, we are going to find whether it is going to terminate or it is going to be repeating the answer. So first we will prime factorize the given denominator. When you divide by 5, you will get 8 5s are 40, then remainder is 5, or 9 5s are 45, 1 5 is 5, it is 91. Now this number is divisible by 7. 1 7 is 7, 3 7s are 21, then 13, then you get 1. So the given number 64 by 455 can be written as 64 by 5 into 7 into 13. Now in the prime factorization of the denominator, you can see numbers 7 and 13. But for a number to terminate, there it should have only factors of 2 or factors of 5 or both factors of 2 and 5. Other numbers are not allowed. If the other numbers are there, then it is not going to terminate. Therefore, it is going to have repeating. It has repeating decimal expansion. Now we have 15 by 1600. Without actually dividing 15 by 1600, we are going to find out whether it is going to have terminating decimal expansion or repeating decimal expansion. For that, we are going to prime factorize the denominator. When you divide by 2, you will get 800. Again dividing by 2, you will get 400. then again dividing by 2 you will get 200, again dividing by 2 you will get 100, again dividing by 2 you get 50, again dividing by 2 you get 25. Now you divide by 5 you will get 5, 5 again dividing by 5 you will get 1. So the given number 15 by 1600 can be written as 15 by 1, 2, 3, 4, 5, 6, 2 power 6 into 5 square. Now you can see only powers of 2 and 5 in the denominator, in the prime factorization of the denominator. There is no other number, so it is terminating. The given number is 29 divided by 343. We are going to prime factorize the denominator. Now dividing by 7, we have 4 7s are 28, then 63, 9 7s are 63. Again dividing by 7 we get 7. Now the given number 29 by 343 can be written as 29 by 7 cube. For a number to terminate, you should have only 2 and 5 in the prime factorization of the denominator. But you can see that there is some other number, that is 7 here. So it is repeating decimal expansion. It has. Now it is not necessary to factorize the denominator. It is already prime factorized there. Now you can see that in the prime factorization there are only powers of 2 and 5. So you can say that it is terminating. For a given rational number to terminate, there should be only powers of 2 or powers of 5 or both powers of 2 and 5 in the denominator. But you can see powers of 7 extra there. So it has repeating decimal expansion. The given question is 6 by 15. Now this 15 can be prime factorized into 3 into 5. When you cancel 1 3 is 3, 2 3s are 6. So you are left over with 2 by 5. You have only the number 5 in the denominator. So you can say that it is terminating. When you prime factorize that number 50, 2 times 25, 5 5s are 25. So this number 35 by 50 can be written as 35 by 2 into 5 into 5. Now 1 5 can be cancelled. 7 5s are 35. What you have is 7 by 2 into 5. So you have only 2 and 5 in the denominator. Therefore it is terminating. 77 divided by 210. When you prime factorize the denominator, you have 105. Then you can divide this by 3, you will have 3 3s are 9, 35. Then dividing it by 5 you will get 7. So 77 by 210 can be written as 77 by 2 into 3 into 5 into 7. 7 and 77 can be cancelled. Even after that, you can see one extra number 3 in the denominator, in the prime factorization of the denominator. For the number to terminate, there should be only prime factors of 2 and 5. Since this 3 is there extra, it has repeating decimal expansion.